In this video, we'll discuss graphing transformations of the basic rational functions 1 equals 1 over x and y equals 1 divided by x squared. So we now apply what we know about graphing transformations to the basic rational functions. Recall the following transformations. F of x plus k shifts a function up k units. Remember that changes on the outside, right? So we're affecting the y value. F of x minus k shifts a function down k units. F of x minus h shifts a function right h units, assuming their h is a positive value. And f of x plus h shifts a function left h units. Recall the interchange kind of goes in the opposite direction that you would think, but if you think about what quantity makes that expression 0, that's typically going to tell you where you need to go, right or left. F of negative x, so remember this is taking the opposite of x, and that occurs across the y-axis. So that is a reflection across the y-axis. The opposite of f of x, which is really the opposite of y, is a reflection of f of x across the x-axis. If you need to visualize the x-axis and y-axis and figure out where the opposite of x occurs and where the opposite of y occurs, do that to help yourself remember. And then a times f of x is a vertical stretch by a factor of a, where a is greater than 1. If a is between 0 and 1, a times f of x is a vertical shrink by a factor of a. Really important to remember is that the vertical asymptote, which was the vertical line x equals 0, and the horizontal asymptote, which was the horizontal line y equals 0, of those basic rational functions 1 divided by x and 1 divided by x squared, must be shifted or moved through those transformations as well. So keep in mind our 1 divided by x had a vertical and horizontal asymptote, and 1 divided by x squared, it was an even function that did the same on the left and right side of that vertical asymptote. So these are the functions that we're going to shift around, and it's a good idea if you can find the intercepts, because those typically will help you, and then think about how we're going to shift that basic function. The first function that we want to shift is f of x equals 1 divided by x plus 2 minus 1. So first of all, identify that this is a shift of f of x equals 1 over x. And it shifts it in this way. We're affecting x, so that's going to go in the opposite of what we think, right? That's going to go to negative 2, so we're going to do left 2 units. And this outer change is going to shift the y values down 1 unit. We know our vertical asymptote. We can figure that out by the shifting, or we can also figure it out by setting the denominator equal to 0, and x plus 2 is equal to 0 at negative 2. So we have a vertical asymptote at negative 2. Now, our horizontal asymptote, remember how we talked about that if the degree of the denominator is larger than the degree of the numerator, the horizontal asymptote is y equals 0. Well, what happens is that that quantity goes to 0 as x gets really, really large, and so the whole quantity would be at 0 minus 1 or negative 1. Now again, we can know that if we look at the basic graph, that horizontal asymptote also has to go down 1 unit. So our horizontal asymptote is down 1. So we have y equals negative 1 is a horizontal asymptote, x equals negative 2 is the vertical asymptote. Furthermore, we could find the x and y intercepts. If we find f of 0, we get 1 divided by 0 plus 2, or 1/2 minus 1, which is 1/2 minus 2 halves, or negative 1/2. So 0, negative 1/2 is the y-intercept. Our x-intercept is found by setting 1 divided by x plus 2 minus 1 equals 0. So if we add 1 to get 1 divided by x plus 2 equals 1, and then multiply each side by x plus 2, so that would be 1 equals x plus 2, and subtracting 2 gives us negative 1 for x. So the x-intercept is negative 1, 0. And we know that the basic shape has to be hugging those intercepts as we approach that vertical asymptote to the left and as we approach infinity. And then the other piece is going to be in the opposite direction. Now, if you wanted to be more precise, you can plug in some values to the left of negative 2. Like if I plugged in negative 3, f of negative 3 is 1 divided by negative 3 plus 2, or 1 divided by negative 1 minus 1. So negative 1 minus 1 is negative 2. So we do actually have a point at negative 3, negative 2. Now, other things I could ask about this function are what are the domain and range, and what's the end behavior. So the domain of this function, remember, is everything except for our vertical asymptote where it's undefined. So negative infinity to negative 2 union negative 2 to infinity. And our range is reading the graph from bottom up. So we have two pieces. We have to go from negative infinity up to this horizontal asymptote. So that would be from negative infinity to negative 1 union, and then the graph picks up again to go from negative 1 up to infinity. The end behavior as x approaches infinity, our function is leveling off at this horizontal asymptote of negative 1. As x approaches negative infinity, y is also approaching negative 1, right? So we're looking at these two ends as we go left and right. Those are approaching our asymptote of negative 1. As x goes to our vertical asymptote, negative 2 from the left, let's say. And we also need to figure out what happens as x goes to negative 2 from the right. As x goes from negative 2 from the left, so that's on the left side of this line, notice our graph is going down, so that's going down to negative infinity. As x goes to negative 2 from the right, our graph is going up to positive infinity. And I need to say y is approaching infinity. In the function f of x equals negative 1 divided by x minus 3 squared, this is a transformation of y equals 1 divided by x squared. So notice we have a negative sign to deal with, and we have this minus 3. So there's two things happening here. When we take the opposite of y, that is a reflection across the x-axis. And then we also have a shift of 3 units to the right. Now remember, what we are shifting and transforming is that basic 1 over x squared. Now what we know, we have a vertical asymptote where the function is undefined. That's where x minus 3 squared equals 0. And that's where x minus 3 equals 0, or x equals 3. And then a horizontal asymptote, notice that the degree of the denominator is larger than the degree of the numerator, which tells us the horizontal asymptote is the equation y equals 0. And again, because we didn't have a shift up or down, that horizontal asymptote of the basic function did not get shifted up or down anywhere. So our horizontal asymptote remains y equals 0. And then we know we have a reflection. So the reflection across the x-axis means that we're going to take the mirror image across the x-axis and then shift that all over 3. So we really know what the basic shape of the graph is. It's going to both be down on either side of this vertical line x equals 3. If we wanted to get more precise points, we could find the y-intercept. If I wanted to find f of 0, that would be negative 1 divided by 0 minus 3 squared, and that's negative 3 squared, or 9, so that's really negative 1/9, which is a negative 0.11. If I wanted to find another point, maybe if I plug in 2, f of 2 would be the opposite of 1 divided by 2 minus 3 squared, which is negative 1 divided by negative 1 squared, or 1, so f of 2 is just negative 1. And maybe we find f of 4, and that's going to be the same value of f of 2, but that's going to be negative 1 divided by 4 minus 3 squared, which is negative 1 divided by 1, or just negative 1. And we know the function is asymptotic to this horizontal line, y equals 0, and to this vertical line, so it's going to hug those lines as we approach them. Notice that this graph has no x-intercepts. Now, the domain of this function is all reals except for where the function is undefined, which is at that vertical asymptote, so negative infinity to 3, union 3 to infinity. And the range is from bottom up, so our graph is happening in the bottom part of the coordinate system, so it only goes from negative infinity and it goes to that intercept, that goes to that asymptote of 0. Right, none of the points of the graph are above that x-axis, so we cannot go above the value 0 in the y for our range. Now our end behavior, as x goes to infinity, and as x goes to negative infinity, we're looking at what do these end pieces do. So as x goes to infinity, we're approaching that horizontal asymptote of 0, y is approaching 0. And likewise, as we approach negative infinity, y is approaching 0. As we approach our vertical asymptote from the right, so as we're going from the right side of 3, we notice that the graph is going down to negative infinity. And as we approach 3 from the left, the same thing is happening. Y is going down to negative infinity. And then one last graph, f of x equals 8 divided by x plus 1 squared minus 2. So this is a transformation of one divided by x squared, and it transforms it by shifting left 1 unit. And notice that we have a stretch factor of 8, and then shifts down 2 units. So again, what are we transforming? That basic 1 over x squared. Our vertical asymptote could be found just by doing the shifting, but it is going to be left 1. We can also find out where it's undefined. Right, x plus 1 squared equals 0 at x plus 1 equals 0, or x equals negative 1. And our horizontal asymptote, again, the degree of the denominator is larger than the numerator's degree, so this term would go to 0, and then 0 minus 2 would be negative 2. And we can find that by shifting the basic graph down 2 units, so that horizontal line at 0 has to go down 2 to y equals negative 2. If we find our y-intercept f of 0, we would have 8 divided by 1 squared, or 8 minus 2, and in fact we already did this in a previous video. We would get 6. So 0, 6, I'll plot it right here. And then our x-intercepts we found in a previous video as well. Let me go back and pull those up. We found they were 1, 0, and negative 3, 0. What do we know about both pieces? They're going to have to both be hugging the asymptotes, but then both going in the same direction, in this case up, because we have not done any reflection at all. So if we want to get just the basic shape of the graph, it's going to have to come something like this. And again, doing it without a graphing tablet and you're doing it on your own paper will probably be a prettier picture. There, that side did better. So we know that this function has a domain of negative infinity to negative 1 union negative 1 to infinity. So either reading left to right or looking for what makes the denominator 0 and excluding that. The range is from, well, nothing is happening down below, right? Down below the line y equals negative 2, nothing of the graph is shown there, so we can't have any values down here in our range. The graph actually starts above that and goes to infinity, so it would be at negative 2 to infinity. Now, the end behavior as x goes to infinity, and as x goes to negative infinity, what is the y value doing? As we're approaching the ends of the graph in the right and left direction, our y value is approaching or leveling off at negative 2. And as x approaches the vertical asymptote, let's say negative 1 from the left, so approaching negative 1 from the left, this piece is going up to infinity. And as x approaches negative 1 from the right, y is also going to infinity. So I hope that gives you some understanding about how to graph functions with transformations. Don't hesitate to contact me if you have questions.